Modern concrete is failing in lots of places in our world. Bridges collapse, sidewalks break, roads not lasting long that need constant repair, buildings crumble. But why? In today's video, let's go look at some of the reasons why modern concrete is failing and what we could do about it, and some ancient tech to fixing the problem. What if we looked at some of the ancient Roman buildings? A lot of their buildings are still standing. What did they know that we didn't? Let's take a closer look. Every year, billions of tons of concrete are poured across the world. It's the foundation of our cities, our bridges, our entire civilization. But here's the problem. Some of it starts failing in just a few decades. Meanwhile, structures built by ancient Roman engineering are still standing after 2,000 years. In fact, some are stronger today than when they were first built. So how did we go from mastering durability to building things that slowly fall apart? Today, we're diving into one of the biggest mysteries in construction: why modern concrete is failing, and why ancient Roman concrete might be the future of sustainable technology. And trust me, the science behind this is going to blow your mind. Concrete is everywhere. It's the most widely used material on Earth, second only to water. Skyscrapers, highways, dams, and sidewalks. We rely on it for everything. Modern concrete is made by mixing cement, water, sand, and gravel. Sounds simple, but there's a hidden cost. Producing cement requires heating limestone to extreme temperatures, which releases massive amounts of carbon dioxide. In fact, concrete production alone contributes about 8% of global CO2 emissions. That's more than entire countries. So not only does modern concrete fail faster, it's also one of the biggest environmental threats we've created. Modern concrete is incredibly strong under compression, but weak under tension. That's why we add steel reinforcement. But here's where everything starts to go wrong. Over time, water seeps into tiny cracks. The steel begins to rust. Rust expands. Putting pressure on the concrete cracks even more. It's a chain reaction. Add in road salt, ocean water, freeze-thaw cycles, and suddenly, structures designed to last a century start crumbling in 30 to 50 years. That's why bridges collapse and why roads constantly need repair. That's why we spend billions just maintaining what we've already built. Modern concrete isn't built to last forever. It's built to be replaced. Now let's go back in time. The Roman Empire built massive aqueducts, harbors, temples, domes like the Pantheon, and many of them are still standing today. But here's the craziest part. Roman concrete wasn't just durable, it was smarter. Instead of steel, they used a mixture of lime, volcanic ash, rocks, seawater in marine structures, and this combination created something incredible, a chemical reaction that continued for centuries. Unlike modern concrete, which weakens over time, Roman concrete actually gets stronger. Here's where things start to feel almost futuristic. Scientists studying ancient Roman structures discovered something shocking. When cracks form, Roman concrete can heal itself. Inside the material are small chunks of lime. When water enters a crack, it reacts with the lime and forms new minerals that help seal the crack from within. It's like the concrete is repairing itself, automatically. This process creates crystals that reinforce the structure over time. So instead of slowly falling apart, it becomes more solid with age. Think about that. We've spent decades trying to invent self-healing materials, and the Romans already had it figured out 2,000 years ago. Want proof this works? Look at ancient Roman harbors. They've been sitting in seawater for over 2 millennia. That's a long time. Modern concrete in the ocean. It erodes, cracks, and fails. Roman concrete? It reacts with seawater to form rare minerals like tobermorite, which actually strengthens the structure. The ocean doesn't destroy it, it improves it. That's something modern engineering still struggles to achieve. So why aren't we using Roman concrete everywhere? The answer is frustratingly simple. It takes longer to set, and it's harder to mass produce. It doesn't fit modern construction timelines. Today's world prioritizes speed, cost, efficiency, not longevity. But that mindset comes with consequences. Constant repairs, environmental damage, shorter building lifespans. If we adopted even part of the Roman method, we could build structures that last centuries instead of decades. Researchers are now trying to recreate Roman concrete using modern techniques. The goal? Combine ancient durability with modern scalability. If successful, we could reduce carbon emissions, build longer-lasting cities, save trillions in infrastructure costs. The future of construction might actually come from the past. So here's the real question. Did we really innovate, or did we forget something important? Because sometimes, the most advanced technology is the one that already stood the test of time. Well, now that we talked about concrete and how the ancient Romans had better concrete for buildings, what if I said their ways also impacted the science of ancient metallurgy? Ever heard of Damascus steel? Well, let's look at all the science behind the steel that was lost to time and uncover the lost science of ancient metallurgy in the next video. Let's discover the technology behind Damascus steel and compare it to what we use today. I can't wait to share these secrets with you.